Imagine 70,000 fans packed into a stadium on championship night. Every ticket scan, every hot dog purchased, and every jersey pulled off the rack generates a massive spike in revenue in a matter of hours. Look at this crowd. During a single match, this living, breathing data engine generates millions of data points, spanning purchases, social reactions, and location pings. But inside the back office, the reality slows down. The ticketing platform, the merchandise system, and the VIP hospitality logs all sit in isolated silos, completely cut off from the central fan CRM database. Calculating the actual financial performance of a match requires analysts to manually pull reports from each of these distinct vendors. By the time they compile the numbers a week later, the window to adjust pricing or restock inventory has closed, leaving millions in revenue untracked. To fix this latency, we have to rethink the backend. Instead of a dashboard that passively displays past reports, franchises need an active intelligence layer. This is Boardroom GPT, an autonomous front office agent. This active command center tracks 30.2 crore in revenue and 93,000 tickets. Look at the VIP hospitality card. It flagged an anomaly. Q2 revenue is 1.3 crore against a 13 crore target, a 90% shortfall. Because the system aggregates the ticketing, CRM, and sales pipeline simultaneously, it removes the human bottleneck. It exposes a severe drop in revenue the exact moment it happens, rather than weeks later during a quarterly review. For an AI agent to perform financial diagnostics, it requires absolute data reliability. An autonomous system cannot function if the streams feeding it have different formatting or varying latency from external vendors. Architecture relies on Fivetran acting as the sync layer. It simultaneously pulls live data from 5 systems, normalizing it into a cohesive pipeline. This pipeline continuously feeds into a central Gemini language model, ensuring access to the freshest possible numbers. Without that instantaneous, continuous background sync, the agent would rely on stale data. This orchestration is what allows for true autonomous strategy. So, with the architecture in place, how do we solve that 90% pre-V hospitality shortfall? This interface shows a direct user query to the agent. An executive simply types, "Why did Q2 VIP hospitality miss target?" into the prompt box. Behind the scenes, the Gemini model reads the prompt and begins a reasoning trace. It scans the ticketing database for purchase velocity, correlates that with social media sentiment, and cross-references the schedule for specific opponent matchups. This readout displays the AI's final analysis. The shortfall was 3.9 crore, 32.5% below target. The analysis identifies pricing rigidity as the tactical failure. The fixed 45,000 rupee price remains static against lower-tier opponents. Finding that specific error would normally require a data team to compare marketing, schedule, and sales spreadsheets for days. Here, the system synthesized those variables and diagnosed a human pricing error in under 10 seconds. Now that we understand the failure, we need a solution. This is where the tool shifts from diagnosing the past to actively mapping out the future. We can ask the system to run a what-if scenario. For example, what happens to stadium revenue if we take $50,000 and shift it to targeted digital ads for the upcoming championship match? This projection screen shows the agent's estimated impact. It projects 4.7 crore in additional revenue, backed by a 78% confidence score. The agent generates the reallocation automatically, allowing an executive to approve and deploy the strategy in real time. By collapsing the distance between pulling data, generating an insight, and taking financial action, the physical stadium and the digital backend operate as one continuous, optimized engine.